Hey guys, this is a video going over just the odd questions on the topic 16A, geometric proofs involving congruent triangles worksheet. We started this in class, and then your homework is to finish the whole thing. I'm going to do the odds. I'd rather you watch this video if you're confused and do these correctly with me. So go ahead, and here we go. Number one. Actually, before we start, let's do a quick review. So in class, for some of you guys, we did this, some of you didn't. So if we didn't, you might want to take out a piece of paper and write this down really fast. For congruent triangle proofs, there's always going to be the same 3 steps. Your first step is to take your given information and make sure it's in the picture, everything's marked in the picture, and then copy it into your proof, okay? And I shouldn't put number 1, it won't always, well, I guess it will be step number 1, but this is the first thing we're always going to do. So let me actually restart this really fast. So the first thing we're always going to do is start with our given. So let's do that in this problem. It says AB is congruent to FG. BC, or segment BC, is congruent to segment GH. And segment CA is congruent to segment HF. So let's make sure it's all in the picture. So here's AB is congruent to FG. BC is congruent to GH, and CA, this wasn't marked, is congruent to HF. Okay, so we've done that. The second step, it's not going to happen in this one, is we're going to look for other things we need to add to the picture. The big 3 for that are vertical angles, shared sides or angles. We're going to do things with parallel lines. And if you're in honors, you're also going to have those overlapping triangles. So sometimes instead of a shared side, you might have a shared angle. So our second thing is go to add all of those things to our picture and then add them to our proof. Our last step, congruence postulate or theorem is, and we have 5 things. These are the new things we just learned. We have SSS, SAS, ASA, AAS. Remember, ASS does not work, but if it's a right triangle, then we have HL, and then AAA doesn't work. So those are our only 5. So if you haven't written this down, these are the 3 steps we're going to go through each time. So let's finish this proof up here. We've marked all of this. There's no vertical angles, no shared sides, no parallel lines. So now we're going to get to our congruence postulate and theorem. So when I look at this, I have 3 sets of congruent sides. So that's SSS. I'm going to go through a checklist. I have 1 set of congruent sides, a second set of congruent sides, a third set of congruent sides. So I know that my 2 triangles, so the proof is always the last statement. So triangle ABC is congruent to triangle FGH because of SSS, and we can use this because all 3 sets of sides have a statement in our proof. Okay, let's skip down to number 3. I'll leave my little sticky note with me as we go. We're going to start with our given. So I'm just going to say segment BC is congruent to segment ZC. Segment DC is congruent to segment CX. That's my given. Let's make sure it's all in the picture. So segment BC is congruent to segment ZC. Segment DC is congruent to segment CX. That's all my given. So now we're going to go to this checklist. Do I have vertical angles? Well, yes, I do. I like to mark my second step stuff in a different color. It helps me, whoopsies, but it might not, just do it if it's helpful for you. So let's add our vertical angles. I can't call these angles C because there's 4 different things that could possibly be angle C or a mixture of them. So I'm going to call this angle BCD. And I'm going to call this angle XZC. And the vertical theorem was it tells me that those 2 angles are congruent. Well, there's no shared sides, there's no parallel lines, no shared angles. So now we're at our last step. What's our postulate or theorem, or congruence postulate or theorem? Well, if I look at just one triangle, I'll notice I have 2 sides, and these 2 sides meet at a vertex, and that's the angle that's marked. So if it's that angle directly in between the 2 sides create that vertex, that's a shared angle, it's directly in between. So this is going to be SAS, because we have 2 sets of sides, the angle is included, it's directly in between. So I have a set of congruent sides I've already talked about, another set of sides, I took care of my angle in my proof, so I'm good to put this in. So my proof is my last statement. And it's because of SAS. Okay, let's keep going. Number 5. Okay, number 5 is a little tricky because now we're going to have some parallel lines. So first step, copy the givens. Okay, let's make sure it's in our picture. So EQ is congruent to QP, and CE is parallel to PR. This does not mean that these two segments are congruent. It just means that they're going in the same direction forever and will never intersect. Okay, so there's my given. Here's my next step. Do I have any vertical angles? Yes, I do. So I'm going to mark them in my picture, and I'm going to add them to my proof. So I'm going to say angle PQR. Make sure that that angle that's marked, that Q needs to be that middle letter, is congruent to angle EQC. That's because of the vertical angles theorem. Okay, shared sides, no shared sides. Ooh, we do have parallel lines. So when we have parallel lines, you're going to use one of two things, either the alternate interior angles theorem, or you're going to use corresponding angles. I spelled corresponding wrong again. Okay. Well, when I see parallel lines, if I can create a Z with my highlighter, and I'll show you what I mean. So here's my parallel line. I'm creating a Z with those two parallel lines. Here's my transversal. The angles that the Z captured, so like the elbows of the Z, those are my alternate interior angles. So I can call this angle P, because there's no other angle in this diagram that could be P. It doesn't have multiple parts like the Q had these 4 things. P is just this one here. Is congruent to angle E, and that's because of the alternate interior angles theorem. And remember, we can only use the alternate interior angles theorem if we already have a statement about our lines being parallel, which we do. Okay, well, we could do a second set of alternate interior angles, but we don't need to because we already have 3 things marked in our picture. So let's see what we have. I have 2 angles and a side directly in between those 2 angles. So that's going to be angle, side, angle. Let's make sure we have everything we need. Here's a pair of congruent sides. This is just talking about sides being parallel. We're not talking about anything being congruent, so that doesn't help us. We have a set of angles being congruent, another set of angles being congruent. So now I can say that my triangles are congruent by A, S, A. Okay, on to number 6. Or sorry, number 7. We're doing odds. Number 7. Here's our list. Okay, let's start with our given. So segment BC is congruent to segment DC. Segment AC is congruent to segment EC. That's all given. Okay, let's start on our list. Vertical angles. Yep, I have a pair of vertical angles. So angle ACB is congruent to angle ECD. That's the vertical angles theorem. Now, I can keep going through this list. I'm not going to find any of these things, but because I have 3 things marked in each triangle, I know I have enough. I guess unless it was AAA or ASS, but it's not in this case. We have 2 sides and an angle directly in between, that included angle. So I can say that triangle ABC is congruent to triangle EDC. We said it's SAS, pair of sides, pair of sides, pair of angles. We're good to go. It's all there. Okay, lastly, number 9, before I'm going to stop this part of the video. Okay. Start by copying our given. Let's make sure it's all in the picture. So GLK, JKL. It also shows that angle G is congruent to angle J. Well, now let's go through our list. Vertical angles, nope. Shared side, yes, I have a shared side. It's right here. I want to say, so I want to indicate that this side is going to be the exact same for this triangle as it is for this triangle because it's the exact same side. And the reflexive property lets us say that something is congruent to itself. You could either write KL again or you could do LK. These are the same segment. Whenever we say that something is congruent to itself, we use the reflexive property of congruence. This has a congruent side, that's why it's POC and not POE. Okay, well, I don't really have to keep going through my list because I have 3 things in each triangle. Notice that I have 2 angles, and this is not not directly in between. This would have been directly in between. So I'm going to do angle, angle, side, pair of angles, set of sides. I got all 3 things in my proof, so I can say that triangle JKL is congruent to triangle GLK because of AAS. And remember, this given is always your first statement, the prove is always your last statement. So I hope that was helpful. This was the same for regular and honor, so I'm going to make 2 different videos to go through the last page. So stay tuned for more videos for the second half of the odds.